Hello everyone, welcome back to my channel. Myself Abhay, currently pursuing BE in Sri Venkateswara College of Engineering. Today I'm going to discuss about superposition theorem. Definition: the superposition theorem is a circuit analysis theorem used to solve the network where two or more sources are present and connected. Superposition theorem states the following: in any linear and bilateral network or circuit having multiple independent sources, the response of an element will be equal to the algebraic sum of the responses of that element by considering one source at a time. To calculate the individual contribution of each source in a circuit, other source must be replaced or removed without affecting the final result. This is done by replacing the voltage source with a short circuit. While removing a voltage source, its value is set to zero. When removing a current source, its value is set to infinite. This is done by replacing the current source with an open circuit. The superposition theorem is very important in circuit analysis because it converts a complex circuit into a Norton or Thevenin equivalent circuit. How to apply superposition theorem? The first step is to select one among the multiple sources present in the bilateral network. Among the various sources in the circuit, any one of the sources can be considered first. Except for the selected source, all the sources must be replaced by their internal impedance. Using a network simplification approach, evaluate the current flowing through or the voltage drop across a particular element in the network. The same considering a single source is repeated for all the other sources in the circuit. Upon obtaining the respective response for individual source, perform the summation of all responses to get the overall voltage drop or current through the circuit elements. Limitations of superposition theorem. The theorem does not apply to non-linear circuits. The requisite of linearity indicates that the superposition theorem is only applicable to determine voltage and current but not power. Power dissipation is a nonlinear function that does not algebraically add to an accurate total when only one source is considered at a time. The application of the superposition theorem requires two or more sources in the circuit. Applications of superposition theorem. Superposition theorem can be used to study the effects of each source separately on parameters such as voltage levels, current levels, etc. Superposition theorem can be used to study how each element affects the overall circuit behavior in large electronic circuits. Superposition theorem can be used how a single element like amplifiers, filters and other electronic elements affect the large analog circuits when any defect arises. Superposition theorem can be used in sensors evaluation where multiple sensors are involved. Each sensor has to studied on the basis of their performance. Superposition theorem can be used in engineering electromagnetics where the fault has to studied in transmission line analysis related to voltage, current, resistance, capacitance, inductance, etc. Superposition theorem can be used for multiple frequency application to analyze the effects of each frequency components and filter response. Solved example on superposition theorem. Example 1. Find the current through 3 ohm resistor using superposition theorem for this circuit. Solution. Step 1. To find I1, consider the 20-volt voltage source alone. Short circuit the other voltage source. To find the current through 3 ohm resistor, it is necessary to determine the total current supplied by the source. If we observe the circuit, 3 ohm and 6 ohm resistors are in parallel with each other. This parallel combination is connected in series with the 5 ohm resistor. The equivalent or total resistance is obtained as below. RT is equal to 5 plus 3 into 6 by 9. So we get 7 ohm. By applying Ohm's law, we get IT is equal to V by RT is equal to 20 by 7 is equal to 2.857 amperes. Step 2. To find I2, consider the 40-volt voltage source alone. Short circuit the other voltage source. Now to find the current through 3 ohm resistor, it is necessary to determine the total current supplied by the source. If we observe the circuit, 3 ohm and 5 ohm resistors are in parallel with each other. This parallel combination is connected in series with a 6 ohm resistor. Hence, the equivalent or total resistance is obtained as below. RT is equal to 6 plus 3 into 5 by 3 plus 5 is equal to 7.875 ohm. IT is equal to V by RT is equal to 4 by 7.875 is equal to 5.079 amperes. We get this by applying Ohm's law. And I2 is equal to IT into 5 by 5 plus 3 is equal to 5.079 into 0.625 is equal to 3.174 ampere. So we get I2 is equal to IT star 5.5 5 by 5 plus 3 is equal to 5.079 star 0.625 is equal to 3.174 amperes. Limited to linear circuits. The superposition theorem only applies to linear circuits when voltage and current have a constant relationship. It cannot be used in circuits including nonlinear components such as diodes and transistors. May not capture all effects. In some cases, interactions between sources can lead to effects that the superposition theorem doesn't fully capture. It assumes that the interactions between sources is negligible, which might not always be the case. It doesn't provide overall solution. The superposition theorem provides solutions for individual sources but doesn't directly yield the overall response when all sources are active. Summing up individual solutions may not always result in an accurate representation of the circuit behavior when all sources are present, not suitable for complex networks. For circuits with interconnected components and complex feedback loops, applying the superposition theorem might not be practical or accurate in capturing all circuit dynamics.